Hey, Algebra, it's come to my attention that a lot of y'all are not watching the videos, which is fine. That's your prerogative. But whenever you ask questions online that I cover in a video, then I'm just going to say, watch the video. Or some of y'all are also not reading the previous questions and answers before you write your own. Still, that's my suggestion is read. A lot of y'all are having the same issues, right? So your questions about the test for number 5 and number 16 are not only covered in a video, but they're also covered online where in whatever classes ask those questions. Now, that going forward, I'm also still getting people sending me private messages on Google Classroom, as well as emails directly to my school account. Stop. Okay, use the comment section. The reason why the comment section is there and the reason why I'm encouraging you to use the comment section is twofold. A lot of y'all will have the same questions, as you can see in first period, to be exact. There was about 5 or 6 of y'all that had the same questions, and I'm able to answer them, in one go. Also in third period, it was pretty evident that a lot of y'all had the same questions, which is great. The second part of that is other people in the class can answer those questions. Okay. So please ask the questions in Google Classroom. You're more likely to get an answer faster. And also, you'll see that other people have the same question as you. Okay. Okay. Um, so the grades are in the grade book. The way that Tomball ISD has told us to do grades now is we're going to have a competency grade, which is just kind of like a standard test. If you get one wrong, you don't get credit for it. If you get it right, you do get credit for it. We also have a completion grade. So it's up to the teacher's discretion as to what grades are going to be completion and what grades are going to be competency. Now, this past week, I've chosen that the quiz will be the completion grade and the test will be the competency grade. Your grades are in the grade book, so if you completed the quiz, you got 100. If you did not complete the quiz, you got a 0. If you completed the test, you got whatever grade you earned. If you did not complete the test, you got a 0. Okay, so please make sure you go back through and take those tests, take those quizzes, and all that good stuff. If you have any issues as to your grade or what it could be or what it should be, please go back and read the test and follow the instructions again. See if you get a different answer. I think you're able to see your answers after you've selected them. All right. If you have any questions about any of the test questions, you can go online and watch the video that covers each of them. All right. I believe that's all. So, I don't know if I posted an answer key. If you can see this answer key for the test, there you go. That's what it is right there. All right, let's get started with the lesson. We have sequences. We're going to start a new lesson called sequences. There are 2 types of sequences that are covered in this lesson that we would normally cover in class. Miss Yanda and I discussed it, and because geometric sequences typically have a lot of questions attached to them, and Mr. Sertival for the district told us that we didn't have to do sequences at all. We're only covering arithmetic sequences instead of geometric sequences. It's the math behind skip counting in numbers. If you have a younger brother or younger sister, or if you remember skip counting from kindergarten and first grade, count by 2s, count by 3s, count by 5s, 2, 4, 6, 8, 5, 10, 15, 20, things like that. It's the math that goes behind those. So let's get started. Our notes are over at types of sequences. This is day 1, arithmetic and geometric sequences. So sequence is a set of numbers that follow a pattern. Each number in a sequence is called a term. And 2 specific sequences we will study, which is false. We're only going to cover one of them. The 2 specific ones are arithmetic and geometric. But we are only covering arithmetic, so we are not covering geometric this year. Here's an example of an arithmetic and a geometric sequence. This would be arithmetic. Do you see how we're going from 2 to 5 to 8 to 11? Well, what's what are we skipping by, right? What is the sequence? What are we changing each value by? Well, if you do 5 minus 2, you can find that the difference between these two are 3. We're increasing the first term by 3 to get to the second term. We're increasing the second term by 3 to get to the third term. And we're increasing the third term by 3 to get to the fourth term. All right. Now, all those little statements that I said, first term, second term, fourth, first, second, third, fourth, the word term, and this 3. All of those values are very important. All right. This would be an example of arithmetic. It's because we're either increasing or decreasing by the same amount every single time. So we're adding 3 each time. Arithmetic, think addition and subtraction. Okay, sequence 2 is something like 2, 6, 18, 54. Well, if we were doing arithmetic, it would be 2 plus 4 would give us 6. But then can we add 4 to 6 and get 18? No, if we added 4 to 6, we'd get 10. So that doesn't work. The whole 2 plus 4 doesn't work for the third term, nor does it work for the fourth term. But we could do 2 times 3. 2 times 3 would give me 6. 6 times 3 would give me 18, and 18 times 3 would give me 54. So we would consider this one geometric. Okay, geometric is multiplication, and it is with numbers greater than 1 and less than 1. So fractions or whole numbers greater than 1. 1, 2, 3, 4, on and on and on. Okay? We can also do improper fractions, 5/3, things like that are greater than 1. So fractions, proper or improper, and then whole numbers as well. But we are not covering geometric sequences. So just understand that there are 2 different types. The arithmetic sequences that we will be covering use addition and subtraction. They will not use multiplication or division, if you want to call that division. All right. The second page talks about the arithmetic sequence. An arithmetic sequence in which each term after the first term is found by adding a constant called the common difference. It's called adding a constant value. You remember that constant value in the example was 3. We added 3 over and over and over again. We call this the common difference. And it has a variable letter of D. Okay? You remember if we peek back at those little bit of notes, I said finding the difference between 5 and 2. Do you remember I said that? Finding the difference between 5 and 2 is 3. So if you don't remember that, you can rewind and look at that portion of the clip and then come back and join us. Now, to find the common difference, you will subtract the first term from the second term. So you will subtract the first term from the second term. So you'll take, I'm going to rewrite that last sequence. It was 2, 5, 8, 11. So 2, 5, 8, 11. We took the first term and we subtracted it from the second term to find a difference of 3. We took the third term, and we took the second term and subtracted it from the third term, so 8 minus 5 will give us a difference of 3, and we took the third term, subtracted it from the fourth term to get a difference of 3 again. So you see our common difference was, our difference between each of these values was common. It was the same across each line. All right. Now, This is the equation. Yours doesn't have all these arrows attached to it, nor does it have that circle, but we'll talk about each one of these. This is the equation for arithmetic sequences, and some of these things are new to you. So having a subtext right here, having the tiny little letters below a letter is something new to you. These numbers just represent the place. So if this were a race between 500 different numbers, this would be first place. We could call this one second place or third place or fourth place or whatever. This number right here, that sub number represents the n. Okay, that just represents so whatever place this is, and n itself represents any number. You could want second place. So let's use our word that we learned today, which is term. You could want the second term, the third term, the fifth term, the eighth term, the whateverth term, the 900th term if we wanted to. And we could put that term that we want, that term number that we want right there, and help us solve this equation. Now, what does each of these other things mean? A sub 1 means the first term. It means the first term, whatever the first term in our sequence is, that goes right here in A sub 1. And that D is the common difference. So if I wanted the 100th term in any sequence, if I were given a sequence like we did here, I would take the first term and I would plug it in for A sub 1. If I want the 100th term, I would plug in 100 right here. And then I would find the common difference between my four terms was 3, and I would put that right here for the common difference. Plug that in, and I would get my 100th term. Okay? A is our variable. A sub n represents the term, our variable term. A sub n represents any term. Right? This is a term, this is a term, this is a term. A sub n represents any term as a whole piece, and that n is just the position. Right? The term, let's call it the term position. So like first, second, on and on and on, third, or 100th. Okay? That's what that represents. We're looking for the whateverth term. This is the value of that term. Okay? And to do that, we would take the first term in the sequence. If we're looking for the 100th term, we'd plug in 100 for n, and we would find the common difference between the first 3 or 4 set, plug that common difference in here, and be able to find that 100th term. All right, I'm almost out of time on this one, so I don't want to get carried away doing explanations. So I'll make a very, very, very short video right after this about the 2 example problems.